Hello, my dear friends. Hello, anyone in live? If anyone in live, say me hi. If anyone is in live, say me hi. Say me whether the video and the audio is clear. Anyone is in live? Anyone is in live? If anyone is in live, say me hi. Hello, everyone. I hope the audio and the video is clear. I hope the audio and the video is clear. I hope the audio and the video is clear. If anyone is in the live, see me hi. Hi Praneeth, hi. If anyone other than him, anyone in the live, see me hi. Now this today's lecture is very important. This today's lecture is very important, and its applications will play a very crucial role in our entire organic chemistry, either in the the next chapter whatever we are going to study, that is which one, alcohols, phenols, ethers and the carbonyl compounds, and everywhere these preparations of the haloarenes and applications part of the haloarenes will play a very crucial role. Hi, good evening Yashwant. Hi Yashwant, hi. Rest any other in live? Any other in live? Now what we do today the lecture whatever I am going to explain, it is very important lecture, and this lecture application only entirely they will repeat. If the NTA either in the mains, either it may be in the NEET, either it may be the JEE mains, either it may be in the NEET, this application will play very crucial role. Hi Bhagya, hi. Good evening Bhagya, good evening. Now the whatever the concept that I was going to explain, preparations of the haloarenes. Before going to the preparations of the haloarenes, what I will do, what are the basics that are involved in the preparations of the halobenzene. For that one, what are the reactions we have to know, how that reactions will show, why the benzene will not show the nucleophilic substitution, direct nucleophilic substitution reaction, that to understand very clearly. First, why it is showing the what aromatic electrophilic substitution reaction, why it is showing, that I will explain. Alcohols Monday చెప్తానన్నాను కదమ్మా భాగ్య, ఆల్కహాల్స్ మండే స్టార్ట్ చేస్తానని చెప్పాను కదా. మండే ఇది ఒక క్లాస్ మిగిలిపోయింది. ఈ హాలోఅరేన్స్ ప్రిపరేషన్స్ అండ్ ఇట్స్ అప్లికేషన్ పార్ట్ ఇది మిగిలిపోయింది. మండే స్టార్ట్ చేస్తాను. రేపు క్వశ్చన్ సెషన్ స్టార్ట్ చేసి మండే నుంచి ఆల్కహాల్స్, ఫినాల్స్, ఈథర్స్ అలా స్టార్ట్ చేస్తాను. ఈ లెక్చర్ ఒక్కటి మిగిలిపోయింది, సో అందుకని ఈ లెక్చర్ స్టార్ట్ చేస్తున్నాను. ఇది కూడా ఇది చాలా ఇంపార్టెంట్. ఈ లెక్చర్ ఏదైతే ఉందో, వాట్ ఎవర్ ద లెక్చర్ ఐ వాస్ సేయింగ్, దిస్ వన్, దిస్ ఈస్ వెరీ ఇంపార్టెంట్ అండ్ ఇట్ ఈస్ application for the upcoming lectures. Okay, now anyone having any concerns, like anything they want to ask? If they want to ask anything now itself, you can ask. Once I start the class, in the middle, if any only the class related doubts only you can ask. Any concerns, any doubts, Anything you want to ask? Anything? Because already in the haloalkane haloarenes SN1, SN2, E1, E2, E1CB and preparations of the haloalkanes and everything we have finished. Now the very important lecture I am going to start, that is a which one? Aromatic electrophilic substitution reaction. Clear? Now the no concerns, right everyone? Now I am starting the lecture. Now be whatever the listen Nana. Now this is very important. I am saying you now this application part of this aromatic electrophilic substitution reaction without the aromatic electrophilic substitution question, NTA they will never and ever stress the question from this one. Every time, every year, either in the NEET, either in the which one? Either in the JEE mains, from this aromatic electrophilic substitution reaction, they are stressing the question. Why? Because actually aromatic electrophilic substitution reaction concept is for hydrocarbon, but the same application of its hydrocarbon itself, they are stressing with the haloalkane haloarene, they are stressing with the alcohols, phenols, ethers, they are stressing with the aldehyde, ketone, carboxylic acid, acid halide, acid amide, they are stressing with the amide. Because on the benzene, if the NH2 if it is attached, then it will become aniline, and it will show the aromatic electrophilic substitution reaction by increasing the electron density at ortho and para positions, and they will ask the reaction. But whatever the concept we have studied in the hydrocarbon, same it will be. Now is it clear? Now my voice is clear? Is my voice is clear or any disturbance it is getting? Yes sir. Okay, fine. Maybe the mic issue, I think so. Sure. Right. Now there is no concerns. Now I am starting the lecture. Be conscious to the lecture, and whatever the questions if I was asking, try to say me the answers to it. If you know, if you don't know, you know right what to do. Just give me the what? Just you give me the question mark so that I can consider that you don't know that question, so that I will start explaining. Right. Now rest any other who are in the live, be conscious to the lecture. Right, fine. First we'll move with the why the benzene it is showing the preparations of the haloarenes, right? Now in the preparation, once moving to the preparations of the haloarenes, first we have to know why. What is the meaning of haloarenes? Haloarenes means this is a hydrocarbon. Not today. I am fine. Not today. I am fine. Not today actually. I will be fine every day. Okay. Your name is somewhat very in a different manner. Not today. Okay. Now this is a benzene, right? Benzene we are having the hydrogens. Clear? Now in this benzene, one hydrogen is replaced and the halogen is added to that benzene. We call it as the halobenzene or haloarenes. Clear? Now in this haloarenes, what are the main important point, what are the main important lecture with this benzene we are going to study? Because here in this benzene, aromatic electrophilic substitution reaction is a very key concept for the to understand which one? To understand the preparations of the haloarenes or reactions of the haloarenes. First of all, my question for you, here we know this is a alkene and this is a one alkyne. This is a one alkane and this is a alkene. Here the alkane, when you have take the HBr, and here also if I take the HBr 2 moles, clear, then here we are getting the one addition product. But here when I was returning in this manner, Here also I was getting the one addition product in this manner. One addition product I was getting in this manner. Clear? Here both the cases for the alkene and the alkyne, HBRs are adding. HBRs are adding. But when I goes to the, for which class is this? Now Sonam, this class is for the JEE mains as well as NEET. This class is for the JEE mains and the NEET, and this is the lecture number of haloalkanes, haloarenes, lecture number 4. Preparations of the haloarenes. To understand the preparations of the haloarenes, first we have to be clear with the aromatic electrophilic substitution reactions. If the aromatic electrophilic substitution reactions, if it is clear, then whatever the concepts we are studying, that it will be clear for you. Is it clear? Are any doubts still? Still you are having any doubts? Is it clear? Now, Sonam, is it clear? Right. Now, for the benzene if I take, and the same HBr reaction if I do, for the benzene if I take and if I do the same HBr if I do, what it will happen? Now we know benzene is a one aromatic compound. Benzene is a aromatic compound. Benzene being the aromatic compound, now what it has become? Now here it is a hydrogen and this carbon is sp3. Now if any carbon, if it is having the sp3 hybridization, clear, that compound will become the non-aromatic, right? Non-aromatic. Making the aromatic compound into the non-aromatic, it is clear, it is what? It is very less stable. Making the more stable compound into the less stable compound is impossible. That's the reason benzene will not show the addition reaction. See, in the statement based questions, first they will ask why the benzene will not show the which one? Addition reaction. Why? Electrophilic or nucleophilic addition reaction. Why the nucleophilic addition reaction as well as the addition reaction benzene will not show? First electrophilic. Why? The benzene is becoming the non-aromatic. First thing. Then next one. Next one, if this benzene want to show the nucleophilic substitution. If this benzene want to show the nucleophilic substitution, then this is a benzene, right? This is a benzene. Benzene, here all the carbon hybridization, all the carbons hybridization is a which one? Here some halogen it is attached. All are sp2 hybridized and we are having the pi bonds. These are the pi bonds. Clear? Now the benzene, these are the pi bonds, it will form. Now if any nucleophile, in this manner the delocalization will be happened in the benzene. If any nucleophile want to be attacked from the back end, what it will happen? This nucleophile itself, it is a negative charge and these pi electrons are also negative charge and it is delocalizing in this manner. Due to that delocalization, what it will happen? Nucleophile is not having the chance to attack from the back end to show the nucleophilic substitution reaction. To show the nucleophilic substitution reaction. But this benzene will show the nucleophilic substitution reaction in the presence of the strong base. OIC, I can, it is sorry to say you that actually my Hindi is not that much good actually. I was from the Hyderabad. I know Hindi, but actually it is not that much fluency and it is not that much efficiency. If I teach it in the Hindi, it may become the comedy class. So that's the reason I was using English. Hindi, actually, the more Hindi I cannot use. Is it okay, OSC? Yeah. If I talk it in the Hindi, it will become like a comedy class. That more Hindi I don't know. Okay, fine, thank you. Right. Okay, fine, thank you. Okay, done. Now that's the reason I was not using the any other language also, because many of the students are joining from the other states are also. Actually the first the motto I created this channel to teach it in my general language, but many of the other state students are also joining, so not to get any interrupt to them, I was teaching in English, that's it. But in Hindi it is very difficulty for me, sorry for that one. Okay, now right, now clear. I can talk generally when we have if you are in the front I can talk, but explanation in the Hindi it will make me very difficult, right? If the nucleophile, if it is comes, this nucleophile what it is from the back end, from the back end if it want to attack these electrons what are there, which are there, that what it will happen, that it will repel, due to that it will not show the nucleophilic, okay, that due to that what it will happen, it will show the nucleophilic substitution, it will not show the nucleophilic substitution reaction, but it will show the nucleophilic substitution reaction in the presence of the very strong base. In the presence of the strong base, in the other manner it will show nucleophilic substitution reaction, it will show, that only I will explain. So the first thing, benzene it will not show the which one, electrophilic addition reaction, done. Second thing, you got to know that nucleophilic substitution reaction benzene it will not show in this manner, directly it will not show in the presence of the strong base, or in the presence of the which one, in the presence of the strong base, or either any electron withdrawing groups are containing at ortho and para positions, there it will show, but direct nucleophilic substitution reaction it will not show. Clear? These 2 points are clear, right? Easy, clear? 2 points are clear. Why the benzene will not show the electrophilic addition reaction, and why the benzene will not show the direct nucleophilic substitution reaction? Is it clear? Are any concerns or any doubts you are having in this? Clear, done. Rest any other? Ishan, good. Yes sir, clear. Right, fine, done. In the two cases it is clear, right? Now we'll move to the which one, electrophilic substitution reaction, right? Now here we are going to move the electrophilic substitution reaction. These reactions are very important, my dear friends. If you remember this, whatever the reaction line by line, only 5 reactions are we having: halogenation, nitration, sulfonation, Friedel-Crafts acylation, Friedel-Crafts sulfonation, Friedel-Crafts acylation. In this 5 reaction, before going to, many of the students they know this reaction, they know the reagent, but they will get a problem where, you know, if suppose one electron withdrawing group if they have given, electron releasing group they have given, on the what basis, on which basis we have to add the electrophile, they don't know. So that everything from the basic level to advanced level I will clear. Whatever the doubt you are having, you can text me. Clear? Right. Here in the electrophilic aromatic substitution reaction, first one, benzene and the benzene homologous, what it will undergo the which one? It will undergo the electrophilic substitution reaction. First one, to show the aromatic electrophilic substitution reaction, any compound to show the aromatic electrophilic substitution reaction, it should follow the 3 steps. Step 1, what is the step 1? Step 1, formation of the electrophile. Formation of electrophile. Step 2, now formation of sigma complex. Formation of sigma complex. Then step 3, clear, elimination of H plus. Substitution means we know, right? One electrophile is added, one electrophile is eliminated. In the cricket we used to see substitution. One player will go and one player will come. In the same way, one electrophile has came, one electrophile has eliminated. That's the reason we are saying this reaction is a substitution reaction. That's the reason first electrophile is adding, right? That's the reason electrophilic, it is adding to the aromatic ring, that is benzene. That's the reason aromatic electrophilic substitution. In the last case, hydrogen is eliminating as a electrophile only. That's the reason aromatic electrophilic substitution reaction we used to say. Done? Right. Now we'll see with the mechanism. In the first step, this is a benzene. This is a benzene. For the benzene, here we are having the one electrophile and one nucleophile. First what we are doing, first we are generating the electrophile. After generating the electrophile, after generating the one electrophile, this electrophile, here we know these are the hydrogens. Now this benzene, because this is benzene is a symmetry, we can shift the pi bond to the any of the carbon. When this pi bond has been shifted to this carbon, clear? Now this benzene carbon will get negative charge and here it will get the positive charge. Done. This electrophile will go and attack to the carbon which contain which charge? Negative charge. Then after adding the electrophile, here it is having the positive charge, right? Now this positive charge should be stabilized. Now this positive charge should be stabilized. Now to this positive charge should to stabilize, here this bond will be delocalized in this manner. Now again here it will get the positive charge and here it is a electrophile. Again this positive charge will be delocalized. Again here you will get the positive charge. Clear? Now this we call it as a, this intermediate we call it as a sigma complex. They will ask you sometimes in a statement based question, they may ask what is the intermediate that is involved in the aromatic electrophilic substitution reaction, that is sigma complex. After the formation of the sigma complex, now the elimination of the which one? Hydrogen, right? Now we know for the benzene, this is a electrophile. Clear? Already the one electrophile added, here it is a positive charge, here it is a positive charge. Then here we are having the one hydrogen, benzene, each carbons we are having the hydrogens that we know. Then this sigma bond, it will be given to the aromatic ring and as the H plus it will be eliminated and the aromatic ring will be restored. Aromatic ring will be restored. In this manner, electrophile will be added to the benzene. See Nana, whatever the mechanism I was said, for the 5 reactions, halogenation, chlorination, halogenation, nitration, sulfonation, Friedel-Crafts acylation, clear, Friedel-Crafts alkylation, all the 5 reactions, same mechanism it will follow. So for the one reaction I will explain the mechanism, remaining cases directly I will explain the how the electrophile generated, then directly we will add to the benzene. Okay, for each and every reactions if I explain with the mechanism, the class duration may increase, so that I cannot cover the n number of questions. Is it clear? Is it clear for everyone? Whatever the mechanism we have seen here, this only. First in the chlorination and everywhere, we have to generate the electrophile. Then after the sigma complex. Then after the elimination of the hydrogen. In all the cases, same mechanism. Same mechanism it will follow. Right. See, first electrophile has been generated. Then after that it has added to the benzene. Then the sigma complex formed. Then after the sigma complex, elimination of the hydrogen takes place. In this manner only it will go. Right. Fine. Right. Next, before going to the another thing, next we have to be very clear here. Next thing, when it comes to the here hydrogen and the deuterium, here also many of the students they will have the some misconception and they will have the confusion here. Now, which one is having the higher bond strength, or both are having the same? Say me, anyone? Anyone? Can anyone say the answer? Can anyone say the answer? Deuterium is having the higher bond strength, or hydrogen? Which one is having the higher bonds? Listen. Here, when it comes to the carbon and the hydrogen and the carbon and the deuterium, carbon and the hydrogen and the carbon and the deuterium, here this carbon and hydrogen bond length is high, so bond strength is weak, and this carbon and the deuterium bond length is small, so the bond strength is high. So in this case also this carbon and the deuterium bond strength is high, so this deuterium easily it will not be break. When it comes to this carbon and the hydrogen, this bond strength is somewhat weak, so very fastly benzene this hydrogen can be given to the any species very fastly. Is it clear? This is a one very key point. It will play very important role in the application. This carbon and the deuterium, it is having the some higher bond strength, due to that easily it will not be broken out. This carbon and the hydrogen, it is having somewhat less bond strength, so that's the reason it can be easily broken out. Is it clear for everyone? This is the one first key point you have to remember. Is it clear? Still you are having any confusion? Normally sometimes they will stress in this manner. How they will stress, you know, C6H6 and C6H5D. Among those two, which is having the higher bond strength? Carbon or hydrogen, or the carbon or deuterium? Clear? Anyone they are having any doubt? Okay, right, clear, right. Now next, another key concept you have to remember, that for the benzene, this is a benzene, right? For the benzene, any lone pair containing species, if that atom directly attached to benzene carbon, it increases electron density on benzene. Clear? This is a one very key point you have to remember. Then next point, the key point. Now this alright. Now if suppose benzene they have given, for this benzene, if any lone pair absent species, if it attached to benzene carbon directly, it decreases electron density on benzene. Clear? How to it will increase and how to it will decrease? Now we will see how it will increase the electrons. That I will explain how it will increase electron density on the ortho para, and how it will increase the meta direction. That I will explain. Listen. So when actually for the benzene, what I said, if any lone pair containing species. Now what are the lone pair containing species? Now this is a OH. This is a lone pair containing species directly attached to the benzene carbon. if the lone pair containing species, if it is directly attached to the benzene carbon, then here the two types of the effects this lone pair containing species will show. What are that? One is a plus M, one is a minus I. One is a plus M and one is a minus I. So among those two, plus M and the minus I, which one will be the more dominating for this lone pair containing species? If it is attached to the benzene carbon, means plus M will show the very high effect. Why? Because here this carbon is of 2p and this oxygen is also of 2p. Both are 2p. Due to that overlapping, this benzene attached to this lone pair containing species will increase the electron density at ortho as well as para positions. It will increase the electron densities at ortho and the para positions. Then, sir, how it will increase the electron density at ortho and para positions? Now we'll see. Here this is a one phenol. This is a one phenol and its oxygen, it is having the lone pair of electrons. Now due to that lone pair of electrons, what happens? This lone pair of electrons will be delocalized and this pi bond will be shifted toward this carbon. Now when this pi bond has been shifted toward that carbon, now oxygen will get the positive charge. Done? Clear? Again this negative charge, again it will be delocalized and this pi bond will be shifted again here. Again this pi bond, when it has shifted here, now here the oxygen will get the positive charge. Clear? Again this negative charge will be delocalized. Again this pi bond will be shifted here. Okay, this is a negative charge and here is the double bond. Now here it is a positive charge and here it is a H. Clear? Again this negative charge, again it will be delocalized. Again what it will restore? Again the same compound what we have taken, that it will be restored. Here it will be the phenol. In this manner, you can see here the when this lone pair containing species, if it is attached to the benzene, now you can see the negative charges on which positions it is there. Negative charges, one is at the ortho to the which one? Lone pair containing species, and para to the lone pair containing species, and the ortho to the lone pair containing species, right? Clear? By this statement I can say that if any lone pair containing species, by that we can say if any lone pair containing species, if any lone pair containing species, if it attached to benzene, increases electron density at ortho and para. Is it clear? Done? Is it clear? Any confusion still? Still any confusion, or is it clear? Right. Now, if any lone pair absent species, if it is attached to the benzene, lone pair absent species, if it is attached to the benzene. Now you can see this is a cyanide. Cyanide is here the lone pair absent. Then what happened? This carbon, it will be increased to the this carbon and the nitrogen. Nitrogen is a more electronegative. It will take this bond pair of electron towards itself. Then when it has taken this bond pair of electron towards itself, now the carbon, here this nitrogen will get the negative charge, this carbon will get the positive charge, right? Now this bond pair of electron will be given to that carbon. When that bond pair of electron has been given to that carbon, now carbon, here this carbon will get the positive charge because its bond pair of electron has been given to this carbon. Now nitrogen will get the negative charge. Then again to stabilize this positive charge of this carbon, now this bond will be delocalized. When that bond has been delocalized, now here we will get the positive charge. Clear? Done. Next, again to stabilize this bond. Clear? Again the bond will be delocalized. Again we will get the positive charge here. Then again to stabilize this positive charge, sorry, this is negative. Sorry, this is negative. Now this is a negative charge, right? Now this is a negative charge. Again to stabilize, this bond will be delocalized. Again this bond will be given to the aromatic ring and the aromatic ring will be restored. Aromatic ring will be the restored. Now if the aromatic ring has been restored, now you can see. Now and which positions electron deficiency we are seeing? Now at ortho, para and ortho. Ortho, para and ortho. Means by this we can say, now minus M groups are lone pair absent species. Minus M groups are lone pair absent species decreases electron density at ortho and para positions. Is it clear? Is it clear to anyone? Still you are having any doubts? Anyone still you are having any doubts in this concept? Anyone having any doubts in this concept? If any lone pair containing species, if it is attached to the benzene, increase the electron density at ortho and para. And if any lone pair absent species, if it is directly attached to the benzene, it decreases the electron density at ortho and para. Anyone still you are having any doubts? Clear, sir. Done. Now, right. Now we'll see. Now based on the which groups will be increase the electron density at ortho and para positions, and which groups will be decreases the electron density at, sir, at meta. What meta? No, actually it is decreasing the electron density at ortho and para direction, and the electron density will be at the meta only. For this, which one? For the cyanide or any minus M groups are attached or any lone pair absent groups are attached to that one. Obviously the electron density will be at the which one? Meta position only. Obviously the electron density will be at the meta position only. Okay, Ishwan? Next. Here, now the based on the lone pair containing species attached to the benzene and the lone pair absent species attached to the benzene, due to that what it will happen, you know, which species will increase the electron density at ortho and para position, which species will decrease the electron density at ortho and para positions, they are asking. Okay, now based on that one, now based on C6H6, based on the electron increasing, based on benzene electron density increasing groups order. First one will be the strong ring activating groups. Strong ring activating groups. Which group? These groups order you have to remember. In the same way you have to remember. Here the first one will be the O minus. Done. The first one will be the O minus. This is among the O minus. Next one we are having the NH2. Next one we are having the OH. Next we are having the NHR2. Next NHR. Clear? Now these are the some groups will increase the electron density at ortho and para. Second category we are having moderate ring activating groups. In this moderate ring activating groups, the category will be the OCH3. Clear? Now acetanilide if it is attached to the benzene. Clear? Next phenyl acetate. Clear? Now this will come. Now the third category weak ring activating groups. Weak ring activating groups. First one will be the which one? CH3. Clear? First one is a CH3. This is very very important. CH3, CH2, CH3. Clear? And the allyl, etc. These are the some weak ring activating group. Next, third one, fourth one, we'll see weak ring deactivating groups. Weak ring deactivating groups. In the weak ring deactivating groups, here we are having the halogens, chlorine, bromine, iodine, etc. Clear? These are the groups will comes under the which one? Weak ring deactivating groups. Now, next one, fifth we are having the moderate ring deactivating groups. Moderate ring deactivating groups. In this moderate ring deactivating groups, we are having the which one? All the carbonyl compounds. Carbonyl groups containing carbonyl compounds will comes under this one. Carbonyl compounds and the SO3H. Done. Next one, sixth one, strong ring deactivating groups. Strong ring deactivating groups. Strong ring deactivating groups. In the strong ring deactivating groups, we are having the NO2, clear, NH3 plus and N plus R3, clear, and the CX3. These are the some groups will decrease the electron density at ortho and para positions. Done. Now these two are the meta directing. These two are the meta directing groups. Meta directing groups. Remaining all are the ortho para directing groups. These groups will increase the electron density at ortho and para directing. Yes, they show the plus M and the minus M. Now I will write the some compounds. Now you have to say me the order. Okay, which one will increase the electron density at ortho and para? Which groups will decrease the electron density at ortho and para? Now you have to say me. First compound order you have to say me. Okay. Now the first one CH3. Now second one is NO2. This is the second. Now third we are having the carboxylic acid. Fourth we are having the phenol. Okay. Now fifth we are having the methoxy. Now sixth we are having the normal benzene. Now you have to say me among the 1, 2, 3, 4, 5, what is the order from the higher to lower increasing electron density on the ortho and para direct? Which among the 6 compound will increase the electron density at ortho and para groups very fastly? What is the order? Among the 1, 2, 3, 4, 5, 6, what is the order? Can anyone? What is the order? What is the order? Which one will increase the electron density at among this? Among the 1, 2, 3, 4, 5, 6, which one will increase the electron density at ortho and para very fastly? Order. Now if you know, try to say me. If not, give me the question mark. I will explain. Sir, 4, 5, 1, 6, 3, 2, 4, 2, 1, 3. Nikhil Kumar is saying 4, 2. No. 4, 5, 1, 6, 3, 2. Good. Now the order will comes under this is a strong ortho para directing group, phenol. Strong ortho para directing group, because this lone pair of electrons will stabilize this lone pair of electron will be given to the benzene very fastly, and it increase the electron density at ortho and para direction very fastly. So the answer is 4. Then after that, next will comes under the moderate ring activating groups, that is a 5. Then after Manan, thank you Manan, thank you for your compliment. Then after that we are having this one, weak ring deactivating group, because this is a toluene. Toluene will comes under the weak ring deactivating group. Clear? Now next will comes under the neutral benzene. 6. Thank you Manan, thank you. Next we are having the 3, that is a carboxylic acid. It will comes under the moderate ring deactivating group. Then will comes under the nitro, that is a last weak ring deactivating group. Clear? Nikhil and Yashwant. Manan, thank you for your compliment. Is it clear? Is it clear for everyone? Done. Right. Now I will write some species. You have to say me that which category that species will come. This is very important. Many of the students, they will make the mistakes here itself. Now why, if this application is clear for you, now you will never and ever do the mistakes in the aromatic electrophilic substitution reaction questions. Now see. Yes, right. This phenol will show two types of the electronic effects. One is plus M effect and one is a minus I effect. But among the plus M effect and the minus M effect, plus M effect is more dominating for the phenol. Clear? Done. Next, this is very important, you have to remember. Next one, when it comes to the methoxy, this is a methoxybenzene. This methoxybenzene also will show the two types of the effect. One is a plus M and one is a minus I. And plus M effect is more dominating for the, can we pole? But that pole option I did not have, Nana. I will search for the upcoming lives. Now how to have that poles, how to give that poles, I will see in the upcoming lectures. Okay, but as of now we don't have any poles. Now here it is having the plus M and the minus I. Next one, many of the students, they will have the confusion here itself. When here we are having the chlorine. Now chlorine, due to the presence of lone pair of electron, what I said, if any lone pair containing species, if it is directly attached to the carbon, it will show the plus M and it will show the minus I. Which effect is more dominating for this one? Pranit, you don't say. Pranit, if you are in the live, don't say the answer. Rest other than him. If the chlorine, if it is present, lone pair containing species, if it is attached to the benzene, it will show plus M effect, and due to this sigma bond pair of electron, it is pulling towards itself, it will show minus I. Other than plus M and the minus I, which effect is more dominating for this chlorine? Many of the students will have the misconception and they will get the confusion in this chlorobenzene only, where the oxygen, it is showing the plus M as well as the minus I, but plus M effect is more dominating. Here the methoxy plus M and the minus I, plus M effect is more dominating. But for the chlorobenzene, plus M and the minus I, which is more dominating? Minus I. May I know the reason? Nikhil Kumar, may I know the reason? May I know the reason why you have chosen the minus I? May I know the reason why you have chosen the minus I? Now actually the more dominating case for the plus M and the minus I is a more dominating for the chlorine, but even though it is a minus I is more dominating, still the chlorobenzene, because the chlorine is weak resonant, no, because here it is a 2p and this chlorine is a 3p. 2p 3p overlapping is somewhat less. Chlorobenzene, still the chlorobenzene increases electron density, at ortho and para positions. Still the chlorobenzene increases at the ortho and para positions. Chlorobenzene it is there, right? Still it will increase the electron density at ortho and para positions. This is very very important molecule. You have to be very careful with this type of the molecule if they are given. Is it clear? Or still I should explain it in the more? Still if you want me to elaborate the explanation, I will elaborate it. Is it clear? Is it clear? Everyone, is it clear? Should I move? Should I move? Yes, sir, done. Right. Right. Yes. Right. Now, which groups will increase the electron density at the ortho para directing group? Which one will give you the meta directing group? Clear. Now, which one is the meta directing group? Now, which effect is more dominating? Which effect is more dominating? That we got to know. Next, this is the very key concept in the haloalkenes, haloarenes. In the haloarenes questions, if they have asking in the NEET as well as the JEE mains, first they will stress with the di-substituted compounds. With the di-substituted compounds. With the di-substituted compounds, they will stress the questions. Clear? If one strong electron releasing group they have given and one ortho position, one CH3 they have given, then the electrophile will go and attack at which position? They will ask you. Electrophile will go and attack to the which position? Here 1 carbon or 2 carbon or 3 carbon or 4 carbon. They will ask you. So whenever this type of the question they have given, many of the students they are making the mistake. They know the concept. They will ask you either the halogenation or nitration or sulfonation or Fidelcraft acylation or alkylation. But they don't know on what basis we have to add the electrophile, and they will pick up the wrong answer. So whatever that misconception or the wrong you are doing in the questions, I will explain very clearly. Now listen. Now if you know, may I know at which positions the electrophile will be attacked and which one is major? This is very very important now. This is very very important. If you know, you say me. If not, say to me, I will explain. Four sir. Major at which position? Major product is at which position? Now here you can see whenever this type of the compounds they have given, here the clear, this is the electrophile. No, not the ortho. Now listen. Here whenever this is electron releasing group, it will also increase the electron density at ortho and para. Now this is also increase the electron density at ortho and para. So when these two are increasing the electron density at ortho and para, then electrophile will go and attack to that ortho and para positions, which electron releasing groups increases electron density on benzene. Is it clear? Here this electrophile will go and attack to that ortho and para positions among those two, which one will release the electron density very fastly on the benzene, on that ortho, with respect to that group, ortho and para positions, it will go and attack. Now you can see here, this is a methoxy. Methoxy will increase the electron density at 4th position. Methoxy group, 4th one is a ortho, and the 2-1 is a para. 2-1 is a para. So this methoxy group, here the OCH3, electron density will increase at 4th position as well as a 2 position. 4th position as well as a 2 position, it will be attacked. So now the products will be, here one electrophile will be at the which one? 2nd position, and one electrophile will be at the 4th position. Is it clear? Done. But among this one, this is a major. This is a major. Right. Next one. I was moving with the another one. You got it right? I think you have cleared with this one. Then if suppose the same OCH3, and if suppose if they have given at the para position, then the electrophile will be added at which position? 1 carbon, 2 carbon, 3 carbon, or 4 carbon. Now you have to say me. Electrophile will be added at which carbon? 1 carbon, 2 carbon, 3 carbon, or 4 carbon? 1 carbon, 2 carbon, or 3 carbon, or 4 carbon? Where it will be added? Where it will be added? 1 carbon, or 2 carbon, or 3 carbon, or 4 carbon, or 5 carbon? One, only one. Yashwant, only one. Other chance are also we are having. 1 it can attack, 4 it can attack. Here it can attack from any of the side. OCH3, both. 1 it can attack, 4 it can attack. Because here for this methoxy, this para position is already occupied. For this methoxy, for this methoxy, already the para position is occupied. If the para position is occupied, so it can attack from any of these 2 ortho positions. Any of its 2 ortho positions. Okay, done. Right. Next. If suppose if they have given next another dye substituted. Now we are going to see. If suppose first one, in the first case we have seen on the basis of different electron releasing groups. Now the same electron releasing groups if they have given. Now these are the same electron releasing groups. Now how to decide the product now? These two will having the same electron releasing power to the benzene. The both will increase the electron density at ortho and para positions. Now in the first case, the one which increase the electron density at ortho and para positions fastly, one which on that basis of its ortho and para I was increased. Now both are same side, both are having the same strength to increase the electron density at ortho and para. Then how to decide? At which positions the attack will be happen? Now I will give you the numbering. Here it is a 1, here it is a 2, here it is a 3, here it is a 4. Para. With respect to which para? Praneeth, with respect to which para? With respect to which CH3 para? Here both are same only, right? This methoxy will increase the electron density at ortho and para. 2 or 3. Both are same. Then here on what basis it will be attacked? 2 and 4. So here now listen. Whenever the 2 methoxy are two same types of the electron releasing, if they have given the same electron, if listen. Now listen, I will explain. When the same type of the electron releasing, if they have given, the same types of the electron releasing if they have given, same types of the electron releasing if they have given, then we are having the this one. If you take this CH3 and if you add, this is CH3 number 1, this is CH3 number 2. For this CH3 number 1, already one ortho is filled. Now the next position will go to the which one? Next position will go to the fourth. Next position will go to the fourth. Here in this manner the fourth it will go. Okay. Now either it has attacked at the fourth also it will become same. If it is attacked at the one position also it will become same. Why? You can see here also 1, 2, 3. Here also 1, 2, 3. If the methoxy or this CH3 if it is attached, CH3 if it is attached at the fourth or 1 number carbon, then also the numbering we are getting 1, 2, 3 only. Here also 1, 2, 3. Anywhere it will be same. Anywhere it will be same. For the CH3 fourth position and the 1 position. For this one, this fourth is ortho. For this one, 1 is ortho. So 1, 2, 3. Anywhere it will be same. Then the another chance we are having to attack at the 2 and 3. Attacking at the 2 and 3. Attacking at the 2 and 3 is more major. Here the methoxy if it is attached, this is major. Why? If it is attacked at the 3, we will get the 1, 2, 3, 4. Clear? If it is attacked here CH3 in this manner, here also we will get the same numbering 1, 2, 3, 4. Is it clear? Is it clear for everyone? Is it clear for the everyone? Is it clear? Now among the 1 to 3 addition, among the 1 to 4 addition, sorry, among the 1 to 3 and among the 1 to 4, which one is more major? Among the 1 to 3, among the 1 to 4, which one is major? Which one is major? Among the 1 to 3 and 1 to 4, which one is major? Among the 1 to 3, among the 1 to 4, which one is major? Right. 1 to 4 is major because here the 3 groups are bulky. Bulky groups are at nearer, so it decreases the stability. Now here the bulky groups are somewhat far away from them. It increases the stability. This is very, very important. No, not 1 to 3. 1 to 4. 1 to 4. Yashwant, 1 to 4. 1 to 4. Because this 1 to 4 bulky groups are some far away from them, right? So okay, done. Right. No problem, Nana. No problem. Right. Now with the electron, now we have seen with the which one? We have seen with one electron releasing with one different one which is strong electron releasing with a less electron releasing and with the same electron releasing. Now we'll go with the both electron withdrawing. Now we'll go with the both are electron withdrawing. Now on what basis we'll decide the product? Now here the attack will be electrophile attack will be at which carbon? 1 carbon, 2 carbon, 3 carbon, 4 carbon. Now you have to say me. Electrophile will go and attack to the which position? Electrophile will go and attack to the which position? Electrophile will go and attack to the which position? Among the cyanide and among the aldehyde, which one will decrease the electron density at ortho and para? If both are electron withdrawing groups, one one which decreases electron density fast, one which decreases electron density fast on that basis of that group meta position electrophile will go. Clear? So the answer, because this cyanide is a strong electron withdrawing group, so that's the reason. Now the electrophile will go and attack to the, at which position? It will go and attack to the carbon number 3. Carbon number 3 it will be attacked. Is it clear? This is a one very key point you have to remember. If any strong electron releasing groups if they have given, now that electrophile will go and attack to that carbon, that position where the strong electron withdrawing group will increase the electron density. Means this one will increase the electron density at a meta position, right? Decreases at ortho and para means. So this one, third group is the cyanide. Clear? Now the one group is also ortho. It can attack at the third and it can attack at the 1 also. 1 also it can attack, 3 also it can attack. But 3 is more major. Next, let's suppose if they have given in this manner, then here it is a cyanide, here it is a aldehyde. Now the electrophile will go and attack at which position? 1, 2, 3, 4. Now which position the electrophile will attack? Next one, next compound also I will write. Now the electrophile will attack at which position? Two and 3. Yes. Either it can attack at the 2, either it can attack at 3. Now in this case, in the second one, where it will attack? The second one where it will attack? In the second one where it will attack? In the second one where it will attack? In the second one case where it will attack? In the second one where it will attack? Meta 2 NO2. Where it will attack? Meta 2 NO2, because among the cyanide and among the NO2 is a strong, here if you take this as a 1, 2, 3, 4, now this meta 2 NO2 meta position is 2 and already one position is fixed, so only at the 3 carbon it will be attacked, because NO2 is a strong electron withdrawing than the cyanide. Right? Only the electrophile is having the chance to attack at this carbon. Here the electrophile will be added. Yes, here the electrophile will be added, so you have to be very careful for this one. Yes, 2 number, good. Next, many of the students, they are getting the mistake and they are doing the mistake in this case. If suppose one electron releasing group they have given and one electron withdrawing group they have given, electron releasing group they have given, electron withdrawing group they have given, then electrophile will go and attack to the which position? Now 1, 2, 3, 4. Which position the electrophile will go and attack? 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 Electrophile will go and attack 2. Yes, electrophile will go and attack at the 2 position. Right. Electrophile will go and attack to the 2 position. No, not 3. Not 3. If suppose electron releasing group and electron withdrawing group if they have given, Then the electrophilic addition, this electrophilic substitution will happen according to electron releasing group priority only. Electron releasing group priority only. So not with the electron withdrawing group priority. Electron releasing group priority only. We have to add the electrophile. Okay. Then here this one is a phenol. So the electrophile can be added at the fourth. Either electrophile can be added at the second position also. Two positions are possible. Here it can possible. Clear? This is very, very important. You have to remember. Many of the students, they will make the mistake here only. Whenever the one electron releasing group and one electron withdrawing group they have given, they will, sir, why not at 4? That's what I'm saying. Here it can attack. Both the cases it can attack. It can attack at the fourth position. It can attack at the second position also. But second position is major. Why? Because methoxy group, para, and which one? For this cyanide, this is meta. So this second here attached. Here this attached here one. If the electrophile, if it is attached here, this is more stable. Why? Because for this OH group, this will become para. For this one will become the meta. So that's the reason this position is very stable. Is it clear? Is it clear for everyone? Done? Right. Now I will write some compound. I will write one compound. Now you have to say me one arbitrarily. I will write a one compound. Here it is a one CH3. Here it is a one NH. Here it is a one benzene. For this benzene, here one carbonyl compound. Yes. One electrophile is there. Now the electrophile will go and add yet 1 number carbon, 2 number carbon, 3 number carbon, 4 number carbon, 5 number carbon, or 6 number carbon. This electrophile will go and attack at which carbon? Now you have to say me. 1 number carbon, 2 number carbon, 3 number carbon, 4 number carbon, 5 number carbon. If this type of the compound, if they have given. Where the electrophile will go and attack. 1 number carbon, 2 number carbon, 3 number, 4 number, 5 number, or 6 number. Where it will be attacked. Where the electrophile is attacked. Where the on which carbon the electrophile is attacked. Yashwant is saying the question mark. Rest any other who are in the live? Sir, it's more like naphthalene, so I think 3. Sir, 2. Fix the answer and say me. Yashwant is said that, okay, question mark, okay, fine. Nikhil is saying that 3. 3 it is not happen, Anna. 3 it is not at all having chance. 3, Pranit, you have said 2. Actually the answer is 2. Why? Why the answer is 2? Because you can see this is a carbonyl compound. This carbonyl compound, what it will do? It will decrease the electron density at 6th position and 4th position. 6th position and the 4th position. Now this nitrogen, it is having the lone pair of electron. This nitrogen, it is having the lone pair of electron. This nitrogen lone pair of electron will be given to the benzene. When it is giving the benzene, it will increase the electron density at ortho as well as the para, as well as the at which one? Here this para position, it will increase the electron density, and ortho position also it will increase the electron density. Done. That's the reason this electrophile will go and readily it will go and attack at the second number carbon. Is it clear? If Nana nickel, listen, if you think it is a 3 carbon ikkada attack avvali ani anukunte, you can see for this NH, this 3 carbon will be the become the meta, but this is the ortho para directing group, not the meta directing group. అందుకే థర్డ్ పొజిషన్లో అటాక్ అయ్యే ఛాన్స్ లేదు, థర్డ్ పొజిషన్లో అటాక్ అయ్యే ఛాన్స్ లేదు. ఇక్కడ ఏముంది, నేను ఏం చెప్పినా ఇక్కడ ఇంతకుముందే ఇక్కడ చెప్పిన కదా, ఒక ఎలక్ట్రాన్ రిలీజింగ్ గ్రూపు ఒక ఎలక్ట్రాన్ విత్డ్రాయింగ్ గ్రూపు రెండు అటాచ్ అయి ఉంటే మనం ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్కి మేబీ సమ్ ఇష్యూ మై ఫేస్ ఇస్ నాట్ విజిబుల్. Okay, wait, let me see what it is. Okay, fine. Be in a line, I mean be in a line. I will cross check once. So I will cross check. Once I will cross check, Nana. Be in a line. Be in a line. Hello asterisk, hello. Be in a live, something it has happened. Oh my god. So I became switched off. Okay, asterisk. Now be in the class. Now the be in the class. Be in the class. I hope the video is clear now. Is it visible? Video is visible? Yes. Right. That's the reason only with the green screen only the background will become black, right? Okay, fine. Yes, sir. Actually I was kept my phone as a camera. I was using my phone as a camera. Unfortunately, I did not plug it into the charging. Now it has become switched off. Now I started with the webcam. I mean like my laptop camera. Okay, done. Right. Sir, everything. Sir, you could continue the class. Okay. Right. 1 minute. Now you got it right. Why it is not going to attack at the which position? Why it is not going to attack at the third position with the NH3? Third position is a meta, and when it comes to the electron releasing group, now electron releasing group and the electron withdrawing group, if it is given, now we have to attack on the basis of the electron releasing group. Now asterisk. Okay, fine. Right. Okay, is it clear? Now next another compound I will write. Another compound, another compound I will write. Then you have to say me on what where the electrophile will be added. one benzene, right? They have given next, okay, better I will go with this one. Now the electrophile will go and attack at which carbon? Now one carbon, now the electrophile will go and attack at which carbon? 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon, 8 carbon, 9 carbon, 10, 11 or 12. Now where it will go and attack? Where it will go and attack? Now the electrophile will go and attack at which carbon? 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 Fourth carbon. Yes, good. Fourth carbon, because this is the oxygen lone pair of electron. Oxygen lone pair of electron will increase the electron density at fourth position. When the oxygen electron density, it will increase the electron density at a sixth position it can attack, 2 position it can attack, 4th position it can attack. But among the four, 4th one is major. Attacking at the 4th position is major. Done? Is it clear? Now, which one is ring deactivating? Oxygen. No. How come? You can see oxygen lone pair of electron. Oxygen lone pair of electron. This carbonyl carbon is attached to this phenyl ring, but this oxygen is attached to this carbon, right? So this oxygen lone pair of electron will increase the electron density at 4th position. That's the reason here it will increase. Here this will increase and this electrophile will go and attack here. Pranit, is it clear? Right. Next one, another compound I will write. Another compound I will write. So other phenyl will act as a electron withdrawing. Now for this one. Now the electrophile will go and attack at which position? Now the electrophile will go and attack at which position? 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon, 8 carbon, 9 carbon, 10 carbon. Now you say me, at which position the electrophile will go and attack? Which position the electrophile will go and attack? 8th. Why? Why it is 8th? Because nitrogen lone pair of electron will increase the electron density at 6th, at 10th and at 8th. And at 8th. Clear? Right. So the electrophile will be added to that. Now I hope it is clear. 8th position only. Yashwant, it is correct only. Yashwant, 8th position lone attack aitadi. 8th position lone attack aitadi. Now I hope it is clear. Now still you are having any doubts? If the dye substituted, if they are given where the electrophile will be added and where the nucleophile will be added, where the electrophile will be added, if they have given the dye substituted, if they have given, still you are having any confusion? Now should I start the reactions? Only 5 reactions we are having. Very fastly I will finish that 5 reactions. Now with the questions, with the n number of the questions, we'll do the with the questions also. We can start the lecture. Should I start the halogenation? Crystal clear. Done. Right. Okay. Right. First one is a which one? First reaction that I am going to teach, that is a halogenation. The first reaction we are going to see is a which one? Is a halogenation. First one we are going to see the which one? Halogenation. Now in the halogenation, first one, benzene plus X2, any halogen, in the presence of Lewis acid FeX3. Now what it will get? You will get the halobenzene. You will get the halobenzene. Now what is the mechanism that it is involved in the halobenzene? Mechanism, here it is a two halogens. First step is making of the which one? Electrophile, right? Now FeX3 is a one Lewis acid. FeX3 is a Lewis acid. This Lewis acid, this lone pair of electrons will be given to the vacant orbital in this manner. When it has given to this vacant orbital, now this halogen will get the positive charge and it will be the FeX3. Then here it will take this bond pair of electron and it will move. Then the what it will generated here, it will generated the one electrophile and will get the XeF4 minus. Now here the electrophile generated, right? This is a electrophile generated. Now this electrophile generated will go and attack to the benzene. How it will be attacked to the benzene? We know this bond is shifted towards this any of this carbon, then one carbon will get the negative charge and the halogen will be added. Here it will get the positive charge. Then after that sigma complex will form. Now sigma complex we know. Then here we are having the hydrogen. That hydrogen it will give to the benzene and as the which one? As a electrophile it will be eliminated. Again the benzene it will be restored. Now this is the mechanism that it is involved in the halogenation. This is a product we will get it in the halogenation. Is it clear? Is it clear? Now if suppose one compound they have given like this, one compound if they have given here the benzene plus Cl2 in the presence of FeCl3 if they have given, what is the product name? Benzene in the presence of, now what is the product name? Now benzene in the presence of Br2 FeBr3. FeBr3. Now what is the product name? What is the product name? One is chlorobenzene. Okay, fine. Next here in the second one, what is the product name? 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 Bromobenzene. Okay, right. Let's suppose, if normal if they have given iodine. Now if suppose if they have given the iodine, now what is the product name? Will the reaction will happen? 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 No sir. Why? Why the reaction will not happen? It is reversible, because here if the iodobenzene if it is formed, now whatever the HI it has formed here, this is a what? This HI is a strong reducing agent. So to destroy this strong reducing agent, this is a reversible reaction. to destroy this reducing agent, here we have to take the KiO3, strong one reducing agent if you have taken. Now this is a HI will form the which one, strong reducing agent, and it is a reversible reaction. It is a reversible reaction. Then in the another manner we can prepare the iodobenzene. How we can prepare the iodobenzene in the another manner? Now we'll see. If the ICl in the presence of any Lewis acid, if they have given, now what is the product here? Here you will get the iodobenzene. Here you will get the iodobenzene. Why? Because here among the iodine and among the chlorine being the more electronegative, it will take the bond pair of electron towards itself and it will generate the iodine electrophile. In this manner it will go and attack. Clear? Now let's suppose, if the benzene if they have given, and Br and the Cl if they have given, and the Lewis acid if they have given, what is the product name? What is the product name? What is the product you will get? What is the product you will get? What is the product name? 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 Chlorobenzene. Chlorobenzene etla? Pranit, chlorobenzene etla ostadi? Bromine chlorine. Edi more? Bromobenzene. ఇది క్లోరిన్ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్ తీసుకొని వెళ్ళిపోతుంది కదా. క్లోరిన్ బీయింగ్ ద మోర్ ఎలక్ట్రోనెగేటివ్, ఇట్ విల్ యాక్ట్ యాజ్ అ న్యూక్లియోఫైల్. బ్రోమిన్ కదా ఎలక్ట్రోఫైల్, ఇక్కడ ఈ ఎలక్ట్రోఫైల్ కదా బెంజిన్ కాడేది. బ్రోమోబెంజిన్, నాట్ క్లోరోబెంజిన్. ఇది చాలా చాలా ఇంపార్టెంట్ రియాక్షన్. ఇట్లాంటి రియేజెంట్స్ తోనే స్ట్రెస్ చేస్తాడు. యూ హ్యావ్ టు బి వెరీ కేర్ఫుల్ విత్ దిస్ టైప్ ఆఫ్ ద రియాక్షన్స్ వెన్ దే హ్యావ్ గివెన్. Is it clear? Next. No. లేదు బ్రోమిన్ క్లోరిన్. నాకు తెలుసు, నాకు అర్థమైంది. నీకు ఆ ఎగ్జాంపుల్ ఏది, అది క్లోరోబెంజన్ నేను చెప్తా ఇప్పుడు. నేను పొద్దున ఎగ్జాంపుల్ ఇదే అనుకుంటా. హైపోక్లోరస్ యాసిడ్ ఇది అనుకుంటా. హైపోక్లోరస్ యాసిడ్ HCl ఇది ఇచ్చిండు అనుకుంటా. ఇదే అనుకుంటా. ఇప్పుడు హైపోక్లోరస్ యాసిడ్ ఇన్ ది ప్రెసెన్స్ ఆఫ్ H+ ఇచ్చిండు అనుకో, ఇక్కడ క్లోరోబెంజిన్ వస్తుంది. ఎట్లా? దిస్ ఈజ్ హైపోక్లోరస్ యాసిడ్. దిస్ ఈజ్ వన్ హైపోక్లోరస్ యాసిడ్. In this hypochlorous acid, here the H+, now this oxygen lone pair of electron very fastly it will give into the H+, then oxygen it will get the positive charge, here the H, and here it is the Cl. Now oxygen bearing the positive charge is unstable, it will take the bond pair of electron towards itself and it will generate here the H2O and the Cl+. This electrophile will go and attack to the benzene. In this manner the chlorobenzene it will get. Now hypobromous acid if they have given, hypobromous acid plus H+ if they have given, then you will get the bromobenzene. Is it clear? Right. Okay, fine. Next. Now next we'll see the another type of the reaction. Second one is nitration. Second type of the reaction that we are going to see, nitration. Here the nitration, this is a benzene plus 2 moles of H2SO4 plus HNO3 at a 60 degree, it will give you the nitrobenzene. it will give you the nitrobenzene. Okay, now how it will give the nitrobenzene? Now we'll see. This is a HNO3. This is a HNO3. Okay. Yashwant, I will post the notes of this session. Complete notes and written notes of mine I will share. Okay. And written notes of mine I will share. Instead of this lecture, handwritten notes I will share in the description box. You can cross check over there. Okay. Now plus complete GOC plus hydrocarbon, it will be there in that PDF. Okay. And as well as haloalkane haloarenes also I will share. Yeah, right. Now you see here, this is a H2SO4 and this is a HNO2. This is a HNO2, right? This is NO2 and this is a OH and the H. Now from here as a H2O it will be eliminated, water molecule. Now when as a water molecule it has eliminated. Now as a water molecule it has eliminated. Now the electrophile NO2 plus HSO4 minus it will form. HSO4 minus it will form. Clear? Now here what are the reacting agents to give the nitration? Nitration ki ee reagent kakunta inkedanna reagents kuda ivvochu. What is that reagents is? What are that reagents is? First one HNO3 plus acetic acid. ACOH and iste, you should not get confused. ACOH is nothing but acetic acid. Next HNO3 ఇచ్చి AC2O అని ఇచ్చిండు అంటే ఇది ఎసిటిక్ anhydride. This is acetic anhydride. In this manner the acetic anhydride will be there. ఓకేనా? ఒక్కొక్కసారి కన్ఫ్యూజ్ చేయడానికి AC2O అని కూడా ఇస్తాడు. AC2O అని కూడా ఇస్తాడు. నెక్స్ట్ ఇంకొకటి ఒక్కొక్కసారి N2O5 అపాన్ హీటింగ్, బెంజిన్ అపాన్ N2O5 అపాన్ హీటింగ్ ఇచ్చినా కూడా NO2 ప్లస్ NO3 మైనస్. క్లియర్? ఇది కూడా one reacting species or reacting reagent that we are going to see in the nitrations. ఒక్కొక్కసారి కాన్సన్ట్రేటెడ్ H2SO4 కాకుండా ఇవి కూడా రియాక్టింగ్ స్పీసీస్ ఇస్తాడు. సో వీ హ్యావ్ టు బి వెరీ కేర్ఫుల్ విత్ దిస్ టైప్ ఆఫ్ ద రియాక్షన్స్ ఆల్సో. డన్. నెక్స్ట్ విల్ సి ఇక్కడ రైట్. నౌ నార్మల్లీ బెంజిన్ if they have given benzene upon concentrated HNO3 and concentrated H2SO4 if they have given. Now we know NO2 plus is a electrophile, it will go and attack to the benzene. This is a NO2 plus. Done. Right. Next, now if suppose nitrobenzene only if they have given, nitrobenzene plus concentrated HNO3 plus H2SO4 if they have given. Clear? Now what are the products you will get? Above 60 degrees Celsius. Now what are the products you will get? And what is that product name? IUPAC name. What is that product IUPAC name? What is that product IUPAC name? Right. That is 1,2 1,3 dinitrobenzene. Yes, good. 1,3 dinitrobenzene. 1,3 dinitrobenzene. This is a 1,3 dinitrobenzene is a products. Clear? Right. Now next, right. Next, yes. Next, if suppose if they have given this one, Mm, plus 2 moles of H2SO4 plus above 60 degree. Now where it will be attacked? 1, 2, 3, 4, 5, 6, 7. Now you see where it will attack. Where it will attack? At which position it will attack? Which position it will attack? Which position it will attack? Three position. Good, 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 good. No. No. Pranit, still you are making confusion. It will attack at the 3 position. It will attack at the 3 position, not 6. It will attack at the 3 position, not at 6. Because here 3 position only. Because here the nitrogen, right? Electrophile. Electrophile, it will generate it as an electrophile, right? But here this is only one meta-directing group. This nitrogen, it will increase the electron density. That's the reason I am saying don't be hurry up. See the molecule and try to add it. See the molecule and try to add it. Okay, right. Okay, fine. Next. Now don't be hurry up. Try to give the answer. Okay. Now, concentrated HNO3 and concentrated H2SO4. Now you say me, at which position it will be added? 1, 2, 3, 4, 5. Where it will be added? Where it will be added? Where it will be added? At which position it will be added? One. Any other? Still any other position? Still any other position? Other than 1, still any other position? Other than 1, still any other position? 1 కాకుంటే ఏదైనా పొజిషన్ ఉందా? 5 మెటా అయిపోతుంది. 3 ఇది ఆక్సిజన్ కదనా, ఆక్సిజన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్ ఇంక్రీజ్ చేస్తుంది కదా. ఇంక్రీజ్ చేస్తే 1 పొజిషన్ ఫర్ దిస్ ఇస్ ఆర్థో పారాడైరెక్టిక్ గ్రూప్ OH. ఇక్కడ ఇంక్రీజ్ చేస్తుంది ఎలక్ట్రాన్ డెన్సిటీ. ద సేమ్ వే ఇక్కడ 3లో కూడా ఇంక్రీజ్ చేస్తుంది ఎలక్ట్రాన్ డెన్సిటీ. సో ఇయర్ ఇట్ విల్ బి ఇంక్రీజ్డ్, ఇయర్ ఇట్ విల్ బి ఇంక్రీజ్. కానీ 5 మెటా అయిపోతుంది కదా. ఇది ఆర్థో అయితే ఈ గ్రూప్కి ఇది ఆర్థో అయితే ఇక్కడ కూడా ఆర్థోనే. కానీ అక్కడ అంతా 5 ఇస్ ఆల్సో ఆర్థో. 5 కూడా ఆర్థోనే. 5 కూడా ఆర్థోనే. రైట్. ఎస్ 1, 2, 3. ఎస్ 1, 3, 5 positions it will attack. Clear? Right. Now next reaction, third type of the reaction we are going to move, that is sulfonation. Okay, sulfonation. In this sulfonation we are going to take the one reaction, that is concentrated H2SO4. Concentrated H2SO4. Concentrated H2SO4 they have given the electrophile, it will generate here the sulfonic acid. Here my dear friends, you have to be very careful, you have to be. Suppose what is the electrophile generated, what is the electrophile generated in sulfonation if they ask. What is the electrophile generated in the sulfonation if they ask? Neutral SO3 is the electrophile. Neutral SO3 is the electrophile, it is generated in the sulfonation reaction. You have to be very careful with this point. With the statement based question they are asking. Here this is a neutral electrophile is SO3. SO3 is the neutral electrophile and it will be added to the benzene. Now when it is adding that neutral electrophile, when it is adding to the benzene, now how it will be added to the benzene now? I will explain. Listen, I will explain. This is a SO3H. So why not the SO3H? I will explain. Listen carefully. Right. Because this SO3H plus is a weak. This is a weak and it is not having that much strength to add. Actually the mechanism it is involved in this reaction is, with the mechanism will go, then you will understand very clearly. Now how the formation of the electrophile will be happened. Formation of electrophile. In this formation of the electrophile, first this is a plenty of the which one? Sulfuric acids will be in the reaction. This is sulfuric acid. Clear? Now another mole of the sulfuric acid. Another mole of the sulfuric acid. Now another mole of the sulfuric acid when it has given. Now from that one sulfuric acid and from one another mole of the which one? Another mole of the sulfuric acid. This proton it will be taken. This proton when it has absorbed. Now in this reversible reaction it will be happen. Now here's a double bond O and here it will get the H2O plus here's a double bond O, O, H and O negative. In this manner you will get. Many of the cases we will think that this is a, here when it has participated in the resonance, then what it will happen, this bond pair of electron it will take and it will be eliminated. This H2O when it has taken this bond pair of electron, when it has eliminated, then here what it will get? This one. When this oxonium ion when it has taken this bond pair of electron, when it has eliminated, now this sulfur will get the which charge? Here the sulfur will get the which charge? Positive charge. To stabilize this positive charge on this sulfur, oxygen lone pair of electron it is having, then this oxygen lone pair of electron will be delocalized. Again this oxygen will get the positive charge. Oxygen will get the positive charge. When this oxygen get the positive charge, then to stabilize that positive charge, now this bond pair of electron will be given, because oxygen bearing the positive charge is unstable. We know oxygen bearing the which one? Positive charge is unstable, so that it will become the which one? It will become the neutral SO3. Is it clear? Is it clear? Right? After when it has become the neutral SO3, after it has become the neutral SO3, how it will attack now I will say. Listen. Here after the neutral SO3 when it has formed, benzene we know this is a benzene. Benzene, this pi bond when it has shifted towards the benzene. Clear? Now here it will get the negative charge. Here it is a positive charge. Now the neutral SO3, this is a neutral SO3. In this manner the neutral SO3 it will be happened in this manner. Now here this sulfur it has attached with the 3 more electronegative groups, means here it is having the high deficiency. Then this negative charge it will be given to this sulfur, and this pi bond will be shifted toward the oxygen. When this pi bond has been shifted toward the oxygen, here the sulfur double bond, here it is a double bond, and here the oxygen will get the negative charge. Then the oxygen, when it is get the negative charge, here it is having the positive charge, right? Here it is having the positive charge. Now here this carbon, here we are having the one hydrogen. This carbon, it is having the not this hydrogen. Now here this carbon, it is having the hydrogen, right? This hydrogen. Now this sigma bond will be given to the benzene ring, and this proton H plus will be abstracted by this oxygen. By this oxygen, by that we will get the benzene sulfonic acid and aromatic ring in this manner. Is it clear? Is it clear? Is it clear? Here why the SO3 is a neutral electrophile, because here the oxygen bearing the positive charge is unstable, so it will take the bond pair of electron and it will be there. Here this proton will be abstracted by the where the H plus is eliminating. In this manner the benzene sulfonic acid you will get. Is it clear, or still you are having any confusion? Sir, can you please give us the schedule of the chapter which you are going to teach in the daily stream? Sorry for that. I will post in the which one? I will post it in the community tab. In the community tab or in the community post, you can cross check over there. Community tab lo gaani community post lo nenu daily lecture schedule nenu post chesta. I will post daily lecture. Repu tomorrow we are having the live on the question section. Complete haloalkene, haloarenes, complete question session. Now the tomorrow's questions, what we are going to do, that it will be helpful for you in your Monday's exam. Monday's exam, direct I cannot say, but questions it will come. Not the direct, but questions it will come. If you attend the live and if you attend and if you have given your answer generally, I mean with own, without searching in any Google or anywhere, easy to easy, you can score above 50 to 60. If you attend tomorrow's live, that question session live sincerely, that too sincerely. Similar it will not be there, but concept will be similar. Not the direct question, but concept will be similar. Concept will be similar, but not the direct question. Okay. Now, is it clear for everyone? Oh, okay, fine. Yashwant, which college you are? ఏ కాలేజ్ అన్నా యశ్వంత్ నువ్వు? నాకు నీ కాలేజ్ షెడ్యూల్ కూడా పెట్టు, నీ కాలేజ్ షెడ్యూల్ క్లాసెస్ ప్రకారం కూడా చెప్తా. హౌ డిడ్ ఇట్ గో? అర్థం కాలే ప్రణీత్, ఏం డౌట్ అన్నా? అర్థం కాలే, హౌ డిడ్ ఇట్ గో? యశ్వంత్, నీకు నా మెయిల్ ఐడి నీకు పంపిస్తా, నా మెయిల్ ఐడి పంపిస్తా నీకు. నీ మెయిల్ ఐడికి నీ కాలేజ్లో ఏమేమి క్లాసెస్ అవుతున్నాయి దాని ప్రకారంగా కూడా నేను నీకు టీచ్ చేయడానికి ఛాన్స్ ఇస్తా. నీకు ఇది ఈ మెయిల్ ఐడికి నీకు ఏమైనా కన్సర్న్స్ ఉంటే పెట్టు, ఓకేనా? ఓకే, రైట్. ఓకే ఫైన్. శ్రీ చైతన్యనా? సరే, ఓకే, డన్. హౌ హీ రోట్ ఎగ్జామ్? ఐ వాస్ ఆస్కింగ్ హౌ హీ రోట్ ఎగ్జామ్. ఓకే. యశ్వంత్, ఎగ్జామ్ ఎలా రాసావు? ప్రణీత్ అడుగుతున్నాడు. ప్రణీత్ ఈజ్ ఆస్కింగ్ హౌ యూ హ్యావ్ రోట్ ద ఎగ్జామ్. యశ్వంత్, ప్రణీత్ అడుగుతున్నాడు ఎగ్జామ్ ఎలా రాసావని. Right, we'll move to the lecture, right? ఏమైంది ప్రణీత్? Right. Ayyo, why only maths? కెమిస్ట్రీ ఏం పాపం చేసింది? కెమిస్ట్రీ కూడా చేయాలి కదా. Friends, why nana? Why the this phone pay number and the Google Pay number? Okay, it is enough. Thanks for your sir. What's the weightage of haloalkanes, haloarenes? I want to thank you by sending you money. No. Prince, it is that is thanks for your the thought what you are having, but I am not here for the money. That once again I am saying you, I am not here for the money and I am not here for the fame. Just I am here to give you the only free content for your whatever the exams you are preparing. Sorry for it. That okay, whatever the money you are want to give it to me on the basis of beginners chemistry, on the basis of the Navin sir, you try to help to someone who are in the need. That it is very happy for me, and send it that pic to my mail ID, that beginnerschemistry97@gmail.com, right? So that I will be very happy. That space prints, whatever the money you want to give it for me, that based on the beginners chemistry, you just give it to any poor people or any needy people and take that one pic and send it to me. I will post it in my personal Insta ID or somewhere in my page. There I will be. Money is not a matter for me, nana. I was working, I was earning. That it is enough for me. My institution is paying for me. I was working. Institution is paying for me. Here it is just to give you the free content so that you will be very happy for you. Just this is my personal time I was giving for you. I was not here for any money. Just you have to be very happy and you have to be success with lectures what I was providing. That's it. You have to follow and you should get the very high marks in the chemistry. That is only my motto. Okay. Thank you, my dear friends. Okay, sir. Soon we will gift you something more. No, Nana. It is enough for me. Your success is a very gift for me. You know, if you are facing any problem in the chemistry, think about the Navin sir. He may clear whatever the doubts we are having, and if you get the good marks in your any entrance exam you are having, okay, whatever the you are having, whatever the misconceptions you are having in your chemistry, that if it is clear, it is enough. Sir, because of your lecture I got 97 out of 100 in yesterday's chemistry. That is good. Thank you, Prince. Thank you for it. Okay, fine, thanks. Right, shall we continue the lecture? No, don't do any such type of the things in college. Okay, because I am here is just to give you the free content. That's it. Right. Okay, fine. Right, okay, fine. Now we'll go the alkylation. Now we'll move the next very important reaction, that is a alkylation. Now in this alkylation we are having the benzene plus alkali halide. in the presence of the Lewis acid, benzene and the alkali halide in the presence of the Lewis acid. Clear? This alkali halide, now this is the Lewis acid AlX3. Now first generation of the which one? Generation of the electrophile is a key step. This is AlX3. Clear? AlX3. Now this lone pair of electron will be given to the vacant orbital. Then what it will happen? Now here it will get the electrophile and here it will get the AlX4 minus. Then whatever the electrophile it has generated, that it will go and add to the benzene and we will get the one what is that? That alkyl benzene you will get. Alkyl benzene. But here the many of the students, they will get the confusion in the Friedel-Crafts reaction. This is a Friedel-Crafts alkylation. In this Friedel-Crafts alkylation, many of the students, they will do mistake where they will in the hurry to predict the product and they will forget the what? Rearrangement of the carbocation. Already I explained very clearly. If any carbocation if they have given, you have to be very careful that you have to rearrange that carbocation, still it feel the more stable carbocation. Here the very key point in this Friedel-Crafts alkylation is carbocation rearrangement takes place. Carbocation rearrangement takes place. Okay, if the carbocation rearrangement takes place, here the first one, this is a Cl. Then in the presence of AlCl3 if they have given, and if they have given the benzene, AlCl3 and if they have given the benzene, now this Cl it will be given to the which one? AlCl3. Then the electrophile will be generated here. Here the electrophile, because this chlorine it will take the bond pair of electron, it will leave and here it will get the carbocation. But here the 1 degree carbocation it has generated, but 1 degree carbocation it is unstable. Then the carbocation can be rearranged to make the which one? 2 degree carbocation. Now this 2 degree carbocation, which has the electrophile it is generated, it will go and attack to the benzene and it will get the in this manner. Now this is the product we will get. This one we call it as a cumene or isopropyl benzene. But in the Friedel-Crafts alkylation, if we want to increase the concept, what? Not only here with the basic one, if we want to strengthen and if you want to increase the level of the question, how they will increase, they will give you the, instead of giving that one, what they will give you? Instead of giving that one, first they will give you the benzene, and they will give you the alcohol. They will give you the alcohol and they will give you the heating. Here with this also, with the alkyl benzene we will get. How? Now this is the alcohol in the presence of H+. Now this alcohol, it will be abstract this proton very fastly and it will convert it into the oxonium ion. Now we know oxonium ion, now it is oxygen bearing the positive charge is unstable, it will take the bond pair of electron itself and it will generate the which one? It will generate the carbocation in this manner. That carbocation it will go and attack to the benzene. It will go and attack to the benzene in this manner. This is also one type of the example used. Next, another type of the example you can stress with the epoxides also. With the epoxides also, now halobenzenes we can prepare. How? If suppose sometime they will give you in this manner, this epoxide and they will give you, and one, which one? The one Lewis acid they will give. One left BF3 if they have given. Then with this epoxides also, now here the which one? Friedel-Crafts alkylations also will be happen. Now this oxygen lone pair of electrons will be given to the vacant orbital of the boron. We know, right, boron, this is N is equal to 1, 1s. Now this is a N is equal to 2, this is 2s2, 2p, 1, right? Here we are having the vacant orbital. Clear? Now due to this presence of this vacant orbital, due to this presence of this vacant orbital, now here it will accept, and this bond pair of electron will be shifted toward the oxygen. Here you will get the positive charge. Here is also there is one type of the electrophile, it will be generated for the which one, for the Friedel-Crafts alkylation. This type of the reactions also they are asking. With the alcohols also R electrophile will be generated. With the epoxides also now electrophile it will be generated. Is it clear? Is it clear? Still you are having any confusion? Still you are having any confusion? Still you are having any confusion? Now, can you say me the answer for this type of the questions? No. We will try to solve. Okay, fine. 3 moles of benzene they have given. 3 moles of benzene they have given. And chloroform they have given. Chloroform they have given. And one AlCl3 they have given. AlCl3 they have given. Now, what is the product? Okay, I will write the options. Options I will write. Now try to say me. This is option A. Option B. This is option B. Now option C. This is option C. Now D, none of the above. This is none of the above. Now try to say me the answer. This is one very beautiful question. NTS favorite question also. This is one beautiful question and the NTS favorite question also. This is one very important and the beautiful question of the NTA. What is the answer? What is the answer you will get? What is the answer you got? Don't know. Now listen. Now whenever the 3 moles of the benzene if they have given, now here you see 3 moles of the benzene if they have given, 3 moles of the benzene if they have given, first this is a CHCl3, right? This is a CHCl3. Done. Now in this CHCl3, first CHCl3, okay. Now AlCl3 we are having. First this chlorine it will be eliminated and it will be given, right? Now the which one it is generated? Electrophile it is generated. Done. This electrophile it will go and attack to the benzene. This electrophile it will go and attack to the benzene in this manner. Here one Cl, here one Cl. Is it clear up to now? This is the first mole. Then after the first mole when it has happened, then the second mole. With the second mole again we are having the AlCl3 excess. Again this chlorine will be eliminated. Again this chlorine will be eliminated. Again this chlorine if it is eliminated, here the H, here the Cl, and here it is a positive charge. And this positive charge will go and attack to the benzene again. This will go and attack to the benzene in this manner. Clear? It will go and attack to the benzene. Again we are having the 3 moles of the benzene they have given, right? Then again we are having the AlCl3 in the solution. Now again this chlorine, it will take this bond pair of electron. Now we will get the diphenyl carbocation. Okay? Now we will get the diphenyl carbocation. Now in this manner the diphenyl carbocation you will get. Again this diphenyl carbocation, it will go and attack to the another benzene. Diphenyl carbocation, it will go and attack to the another benzene in this manner. Is it clear? This is advanced question. This is one advanced question. Is it clear? Will you try? Should I give the on this same concept only? Should I give the another question? On this same concept only should I give the another question? On this same concept only should I give the another question? We'll do more. Right. On the same concept only I will give the another question. Try to say me. No. Excess benzene is excess. Benzene is excess plus CCl4 AlCl3. Benzene is excess, CCl4 AlCl3. Now option A, this is the option A, this is the option A. Next option B. Actually this is arbitrary question. This is my prediction question. My prediction. Whether this type of the molecule will be exist or not, we don't know. Option A. Yes, good. Option A. Because all the CCl4s will be eliminated and you will get the what? Tetraphenyl carbon you will get. Yes, directly you will get, because all the CCl4s will be eliminated and the pH will be attached. Okay. Next one very interesting question I will give you. Now you have to say me with IUPAC name. With IUPAC name you have to say me. Yeah. Similar question was there in the signature. Oh, okay. Similar question also. Option A. Good. Next one. Oh, Ankush Buyam, no bandidiya live alli. Enappa nale rajana adike bandidiya. Right. Now, if suppose chlorine and fluorine in the presence of anhydrous AlX3 if they have given. Anhydrous AlX3 if they have given. What is the compound IUPAC name? Acha, ಹೇಗಿದ್ದೀರಾ? ಹೆಂಗ್ ನಡ್ತಾ ಇದೆ? ಅಚ್ಚಾ ಹೇಗಿದ್ದೀರಾ? ಹೆಂಗ್ ನಡ್ತಾ ಇದೆ? ಎಕ್ಸಾಮ್ಸ್ ಮುಗಿತಾ? ಎಕ್ಸಾಮ್ ಮುಗಿತಾ? ಆನ್ಯುವಲ್ ಎಕ್ಸಾಮ್ಸ್ ಮುಗಿತಾ? Now what is the product IUPAC name? Can you say me the answer? Product IUPAC name? What is the product IUPAC name? ಎಕ್ಸಾಮ್ಗೆ 2 months ಇದೆ. ಅಚ್ಚಾ ಹೌದಾ? ಓಕೆ ಫೈನ್. ಸರಿ. Now what is the answer for this one? 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 Sir, 1-fluoro-3-phenyl propane. Wrong. Wrong. Pranit, I know. I thought that you will give the answer of this one only. 1-fluoro-3-phenyl propane. I thought. But it is wrong. But it is wrong. This is wrong. Now you say me reactivity. Here they have not mentioned any H2O. Here they have not mentioned any H2O. Here they have not mentioned any H2O. If the H2O is not note H2O, if it is not, if the H2O is not mentioned, if the H2O is not mentioned, fluorine is good leaving group, because now reactivity order with the alkali. Now fluorine greater than, chlorine greater than, bromine greater than. Clear? Now this is the reactivity order if the H2O is not given. For the alkali halides, if the H2O, if it is not given, if the H2O, if it is not given, now the fluoride, chloride and the bromide is a very high reactive. So the fluorine will be eliminated first. So no, not 1,3 diphenyl propane. No, fluorine will be eliminated. Now the product you will get in this manner. Now the product you will get it as a now here it is a carbocation. Now here 1, now here it is 2, now here it is a Cl. So here 1, 2, 3, 1-chloro-3-phenyl propane, 2 moles kada. No, only 1 mole. Here this point you have to be very careful. Remember this point. These points only, this type of the small mistakes only you are doing. Okay? If the H2O, if it is not mentioned, fluorine is a good leaving group. Reactivity order for the alkali halides will be in this manner. If the H2O, if they are given, the chlorine will be the good leaving group. Is it clear? Anyone still they are having any doubts? Anyone still they are having any doubts? No doubts, sir. Shall we move, or we'll do some other examples? Any other examples we'll do? Still we'll do some high level of the questions from this concept. We'll do some high level questions from this concept. Can we do some high level questions from this concept? Okay, sir, done. Now right. Okay, fine. If suppose here this is a 1 benzene and 1 cyclopropane. If suppose if they have given the cyclopropane in the presence of HBr and AlBr3 Lewis acid, then what is the product name? What is the product name? ప్రోడక్ట్ నేమ్ ఏంటి? What is the product name? Product name. Sir, cyclopropyl benzene. Cyclopropyl benzene. Cyclopropyl. No. Not cyclopropyl cyclopropyl. No, not cyclopropyl. Not cyclopropyl benzene. Not cyclopropyl benzene. Think. That's the reason I said this is somewhat high level of the question. Sir, propyl benzene. Yes. Oh, propyl benzene. No. Propyl benzene కాదు. కరెక్టే వచ్చావు కానీ బట్ స్టిల్ సంథింగ్ మిస్సింగ్. స్టిల్ సంథింగ్ ఈస్ మిస్సింగ్. కరెక్టే వచ్చినావు. హాలోజినేషన్ అండ్ దెన్ ఆల్కైలేషన్, కానీ ఎక్కడో మిస్ అవుతున్నావు. హాలోజినేషన్ కరెక్టే చేసినావు, ఆల్కైలేషన్ కరెక్టే చేసినావు, కానీ ఐసోప్రోపైల్ మరి అది చెప్పాలి. ఐసోప్రోపైల్ అది మరి 1 degree కార్బోకేటైన్ ఇట్ విల్ బి రీఅరేంజ్ రైట్ ఇన్ ద ఫ్రీడెల్ క్రాఫ్ట్ ఆల్కైలేషన్. రీఅరేంజ్ అవుతుంది కదా. మరి రీఅరేంజ్ అయినప్పుడు రీఅరేంజ్మెంట్ చూడాలి కదా. రీఅరేంజ్మెంట్ ప్రోడక్ట్ కూడా రీఅరేంజ్మెంట్ ప్రోడక్ట్ ఆల్సో యూ హ్యావ్ టు సీ రైట్. బ్రాంచింగ్. ఇప్పుడు దిస్ వన్, దిస్ ఈస్ ద I reactive. This I reactive, here the Br will be added. Clear? Then after the Br, here the AlBr3 we are having. AlBr3. In this AlBr3, bromine will be eliminated. Then we'll get the 1 degree carbocation. But 1 degree carbocation it is unstable. Rearrange it will be happen. When the rearrangement it will happen, now we will get the isopropyl benzene. No, isopropyl benzene you will get. Isopropyl benzene you will get. Okay, next very important question. Now isopropyl, if suppose in this manner they have given 1 2 3 4 phenyl but1ene, 4 phenyl but1ene upon H3PO4, upon H3PO4. Now what is the compound name? Now A, this is A. Now B, this is B. Now C, now this is C. Now D, none of the above. 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 Question. What is the answer? What is the answer for it? One C sir. కాదు, సి కాదు. నో సి అయితే కాదు. సి కాదు. ఆన్సర్ ఈస్ బి. వై? బికాస్ ఇక్కడ వై? బికాస్ this is a internal, this reactions we call it as a, which type of the reaction? This one internal reaction, internal, how the internal reaction it will be happened. Now internal alkylation, these reactions are known as a internal alkylation, intramolecular. How? Because here you can see now this is a H3PO3, this is H3PO3, it will generate the electrophile H plus, it will generate the electrophile. Now this carbanion will be more stable at the 1 degree position. 1 degree carbanion is more stable, we know. Then here this radially this H plus will be attacked here. When this H plus has been attacked here, then here it will get the positive charge and here it will get the positive. Now the benzene, this pi bond will be shifted here. When this pi bond has been shifted by the benzene, now here it will get the positive charge, here it will get the negative charge. Clear? Here it is having the positive charge and here it is having the CH3. Now this positive charge and this negative charge will form the bond. Now give the numbering 1, 2, 3. Clear? Now the phenyl ring, this is the phenyl ring, and here it is a 3, here it is a 2, and here it is a 1. One position we are having the CH3 and this one will form the bond. Now here we are having the hydrogen, right? Now this hydrogen again it will be given to the solution, again to the aromatic ring. Then here this one will be the restored. Now this is a CH3. Is it clear? Is it clear? Should I give the another model of the question for this one? Should I give the another model of the question? Right. Now another model of the question I will give you. In this manner is anhydrous AlCl3. Anhydrous AlCl3. Alright. Now say me the answer. Now say me the answer. A. B. Now B is, this is B. Now C will be the, now this is a C. D, none of the above. C, none of the above. C is none of the above. C is none of the above. C, sir. Yes, good, good, good. Answer is C. Yes. Now here it is. Now 1, 2, 3 and here it is a methyl and here is a positive charge. Now here it will get the negative charge and this will form the bond. Now give the numbering 1, 2, 3. Clear? Now this is a 1, 3, 2 and here it is a 1. One position we are having the 2 methyls and it's clear. Ante AlCl3 chlorine వెళ్ళిపోతుంది కదా, క్లోరిన్ వెళ్ళిపోయిన తర్వాత ఇక్కడ పాజిటివ్ చార్జ్ వస్తుంది, ఇక్కడ నెగిటివ్ చార్జ్ కదా, ఈ నెగిటివ్ చార్జ్ పాజిటివ్ చార్జ్ విల్ ఫార్మ్ ఏ బాండ్ అండ్ ఇట్ విల్ గివ్ ద బెంజీన్. క్లియర్? విపుల్ అర్థమైందా? విపుల్ అర్థమైందా? గాట్ ఇట్? విపుల్ డిడ్ యూ గాట్ ఇట్? Next. Next type of the reaction if they have given. Next step. Next question. Yashwant, are you there? Yashwant, are you in the class? Yashwant, here the Cl, here the Cl. AlCl3. Yes. Now what is the product? ఇక్కడ ఏది ప్రోడక్ట్ ఏంది? A, B will be the, this is B, this is a B. Now the C will be the, now this is a C. D, none of the above. D is the none of the above. D is the none of the above. D is the none of the above. ఏ కాదురా, చూడు మళ్ళా, ఏ కాదు, ఏ కాదు, ఏ కాదు, ఏ కాదు, A is not the answer. Answer is C, not the A. Answer is C. Why? Because this is the phenyl ring, right? Okay. Now this phenyl ring, now here the clear, here the chlorines, here the chlorines are there, done in the presence of AlCl3. Here this chlorine will be eliminated first. Okay, first the electrophile will be generated. Now in this manner the electrophile will be generated. Here it is a Cl. Okay, first it will go and attack to the benzene. First it will go and attack to the benzene in this manner. Here it is a Cl and it is there. Okay, malla AlCl3 untadi kada solution lo. Again that AlCl3, again this chlorine will go and attack. ఇక్కడ ఏం చార్జ్ వస్తుంది, మళ్ళీ పాజిటివ్ చార్జ్ వస్తుంది కదా, పాజిటివ్ చార్జ్ మళ్ళీ బెంజీన్కి అటాచ్ అవుతుంది. మళ్ళీ బెంజీన్కి అటాచ్ అయినప్పుడు it will get. Clear? Answer is C. Answer is C, not A. Clear? Still any confusions? Clear అయిందా? కన్ఫ్యూజన్ లో ఉన్నారా? Still any confusions? Okay. Next one will be the acid acylation. Next question, acylation, Friedel-Crafts acylation. In this Friedel-Crafts acylation, many of the times they will ask you Friedel-Crafts acylation and the Friedel-Crafts alkylation, which is more stable among them. Can anyone say Friedel-Crafts acylation and alkylation? Friedel-Crafts acylation and the Friedel-Crafts alkylation, which is the stable among them? Which is stable among them? AlX3, that is the AlX3. Done. It will take this bond pair of electron, acylation. Why? Because it will take this bond pair of electron towards itself. Now here the halogen will get the positive charge and it will form the bond with AlX3. Now it will take this bond pair of electron towards itself. When it has taken the bond pair of electron towards itself, now the carbon, here it is having the positive charge, and oxygen it is having the lone pair of electron. That lone pair of electron will be restored. Now in this manner it will form the which one? Resonance. In this manner it will be in the resonance. This will be the more stable carbon, because this is a more stable resonating structure and it is stable. Clear? Done. It will go and attack to the benzene and it will give the acylation. Acylation. Hi Yashwant, hi. ఇప్పుడు నేను ఒక మంచి క్వశ్చన్ రాస్తా, ఆప్షన్స్ మంచిగా చూడండి, కరెక్ట్ చెప్పాలి. ఓకే, ద వన్ హూ ఆర్ ఇన్ ద లైవ్ ఒకసారి హాయ్ చెప్పండి. లైవ్లో ఎవరెవరైతే ఉన్నారో ఒకసారి హాయ్ చెప్పండి. నేను ఒక మంచి క్వశ్చన్ రాస్తా, మీరు తప్పు చేయడానికి 100% it is having a chance. Max to max you are having a chance to do the wrong in this question. యశ్వంత్ ఓకే, ప్రణీత్ ఉన్నాడు. ప్రణీత్ చూడు, ఇప్పుడు నేనేమి ఇస్తున్నా అంటే, ఓకే, దిస్ ఈస్ ద వన్ సబ్స్ట్రేట్. ఈ సబ్స్ట్రేట్కి యాసిడ్ క్లోరైడ్ ఉంది, యాసిడ్ క్లోరైడ్ ఇన్ ది ప్రజెన్స్ ఆఫ్ AlCl3. ఓకేనా? ఓకే, now what is the stable product it will form? Option A, ఇది A. ఓకే, now B, ఇది B, రైట్. C, ఇది C. Now D, none of the above. What is the answer? చెప్పండి, వాట్ ఇస్ ద ఆన్సర్? Tertiary butyl benzene. Sir, when you will have your dinner? It's 10, sir. I will eat, Nana. Don't worry about me. I will eat. Don't worry. I will eat at 10:30 or 10:45, like that. Let your concepts and everything let's clear first. That it is enough for me. That it will feed me. Cheppanana, this is very interesting question. This is one very interesting question. సార్ ఏనా? నాకు తెలుసు ఏ అనే అంటారు అని. బట్ యూ సేడ్ వి విల్ బీ రాంగ్. నాకు తెలుసు. ఆన్సర్ ఇస్ బి. ఇప్పుడు చెప్పండి, కెన్ యూ ప్రిడిక్ట్ ద రీజన్? Can you predict the reason? Can you predict the reason? Can you predict the reason? Answer A అంటారని నాకు తెలుసు, కానీ ఆన్సర్ ఇస్ బి. యాక్చువల్లీ దిస్ ఈస్ విచ్ డైరెక్టింగ్ గ్రూప్? This is which directing group? Aldehyde is which directing group? This is aldehyde is which directing group? Aldehyde is which directing group? Aldehyde is which directing group? Meta. Then for that meta direction, this group it should be there, right? Then for this one, if you see this one, this is to the which one? Para. But for this one, this is the para, right? But this para position, this one will not be added. Now here if it is this carbonyl carbon, if it is attached at the meta position, then what happened? This meta compared to this one, this meta position, it is more stable, right? Instead of doing at the para position, here this meta position, it is more stable. Is it clear? Here it will not show any plus H effect. My dear friends, it will not show any plus H effect. ఇక్కడ ఆల్ఫా హైడ్రోజన్స్ ఏమీ లేవు. బెంజిన్ మీద ఆర్థో పారా డైరెక్టింగ్, బెంజిన్ మీద ఎలక్ట్రాన్ డెన్సిటీని పెంచడానికి ఇక్కడ ఆల్ఫా హైడ్రోజన్స్ లేవు. ఫస్ట్ ఆఫ్ ఆల్ there is no any plus H effect. This whatever the methyl groups it has attached to the benzene, whatever the methyl groups it has attached to the benzene, it will not increase the electron density at ortho and para positions. It will not increase the electron density at ortho and para positions. అర్థమైందా? ఇక్కడ అటాక్ అవ్వడానికి బల్కీ గ్రూప్స్ ఉండడం వల్ల లెస్ స్టేబుల్ కాబట్టి ఇక్కడ అటాక్ అవుతుంది. అర్థమైందా? ఈజ్ ఇట్ క్లియర్? రైట్. ఒక కన్వర్షన్ క్వశ్చన్ రాస్తా. విల్ యూ ట్రై టు సే ద ఆన్సర్? ఒక కన్వర్షన్ క్వశ్చన్ రాస్తా. ట్రై టు సే మీ ద ఆన్సర్. Okay, this is AlCl3. This is AlCl3. Use A upon NH2 OH minus gives B upon SCO2 heating gives C. What is the C over there? 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 తెలిస్తే చెప్పండి, తెలియకపోతే క్వశ్చన్ మార్క్ ఇవ్వండి. I will explain. I will explain. If you know the answer, try to say me. If not, I will end. తెలిస్తే చెప్పండి, తెలియకపోతే వాట్ ఇస్ ద ఆన్సర్ తెలియదు. ఓకే ఫైన్. ఫస్ట్ ఇదేమవుతుందన్నా, ఇది Cl3, Cl it will be eliminated. When the Cl it has eliminated, నువ్వు వస్తే ట్రై చేయి, రాకపోతే 1 2 3 4 కదా. ఓకే, 4 నెంబర్ కార్బన్ మీద ఉంది. ఇది 1, ఇది 2, ఇది 3. దిస్ ఇస్ ద 4 నెంబర్ కార్బన్. 4 నెంబర్ కార్బన్ ఈస్ ద పాజిటివ్ చార్జ్. హియర్ ద బెంజిన్ ఇట్ ఈస్ హ్యావింగ్ ద పాజిటివ్ చార్జ్, రైట్? ఇక్కడ నెగిటివ్ చార్జ్ ఉంటుంది కదా. ఇట్ విల్ ఫార్మ్ ఏ బాండ్ లైక్ దిస్. నాప్థలిన్, 2 బెంజిన్స్ కాదు, నాప్థలిన్ అది. That we call it as a naphthalene. ఒకటి, ఇది 1, ఇది 1 and 2, ఇది 3, ఇది 4. We are having this one and this one. Okay, now upon NaNH2 base, what it will happen? It will convert it into the alkane. Upon SCO2, it will convert into the naphthalene. Hydrogen aromatization. Good. Naphthalene. Right. Good. Almost అన్ని types of the reactions of the hydrocarbons కి కంప్లీట్ చేసిన నేను. I will end the session here. ఇక్కడికి ఎండ్ చేసేసా సెషన్ని. ఏదైతే న్యూక్లియోఫిలిక్ అరోమాటిక్ అడిషన్ ఎలిమినేషన్ ఉందో అది ప్లస్ రేపు ఒక గంట ముందు 6 o'clockకి లైవ్ స్టార్ట్ చేస్తా. ఆ గంట ఎక్స్ప్లెయిన్ చేసి 7:30కి క్వశ్చన్ స్టార్ట్ చేస్తా. ఓకేనా? ఓకేనా? ఈజ్ ఇట్ క్లియర్? ఒక్కటే అడిషన్ ఎలిమినేషన్, నెక్స్ట్ ఇంకొకటి మన వాట్ న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్. ఆ రెండే రియాక్షన్లు ఉండిపోయినాయి ప్రిపరేషన్స్ ఆఫ్ ద హాలోఅరేన్స్లా. ఇది ఎక్స్ప్లెయిన్ చేయడం వరకు ఇంత టైం అయిపోయింది. ఓకేనా? అవి రెండు రేపు పొద్దున ఒక 1 అవర్ ముందే క్లాస్ స్టార్ట్ చేసి అది ఎక్స్ప్లెయిన్ చేసి రేపు క్వశ్చన్ స్టార్ట్ చేస్తా. జేఈ మెయిన్స్ కంప్లీట్ ప్యాటర్న్ ఆఫ్ ద హాలోఅల్కీన్ హాలోఅరేన్స్ క్వశ్చన్స్. క్లియరా? ఓకే, అది మ్యాక్స్ టు మ్యాక్స్ 6:30 కన్నా 7:30 కన్నా స్టార్ట్ చేద్దాం. నేను లైవ్ పోస్ట్ చేసి పెడతా, అది ఏ టైంకి అనేది ఒకసారి మీరు చూసుకొని జాయిన్ అవ్వండి. కాకపోతే ఒకసారి కాన్సెప్ట్ని కూడా రివైజ్ చేసుకోండి. రేపు క్వశ్చన్ సెషన్ కాబట్టి తొందరగా ఒక 1.5 అవర్ 2 అవర్స్లో కంప్లీట్ అవ్వడానికి చూద్దాం. మార్నింగ్ పెడదామా? ఈవినింగ్ పెడదామా? మార్నింగ్ బెటరా, ఈవినింగ్ బెటరా? ప్రణీత్ ఏందమ్మా, మార్నింగ్ పెడదామా, ఈవినింగ్ పెడదామా? మార్నింగ్ ఈజ్ గుడ్. మార్నింగ్ అందరూ ఉంటారో ఉండరో నానా, అంటే నా సజెషన్ ఏంటంటే మీరు మార్నింగ్ చదువుకుంటారు కదా, ఈవినింగ్ ఒక రివిజన్ టైప్ అయిపోతుంది. నేనేమంటున్నా అంటే మార్నింగ్ చదువుకుంటారు కదా, ఈవినింగ్ రివిజన్ టైప్ అయిపోతుంది. అట్లా ఈవినింగ్ మీరు మార్నింగ్ చదువుకొని ఉంటే ఈవినింగ్ అది రివిజన్ లెక్క అయిపోతుంది, ఎగ్జామ్లో ఈజీ అయిపోతుంది. సో ఆల్మోస్ట్ మ్యాక్స్ టు మ్యాక్స్ ఎగ్జామ్ పేపర్ విల్ బి వెరీ ఈజీ బికాస్ యు నో ఐ వాజ్ నాట్ ప్రిపేర్డ్. మీకు తెలుసు క్వశ్చన్ పేపర్ నేను ప్రిపేర్ చేయలేదు. ఇట్ వాస్ ప్రిపేర్డ్ బై ద some other branch that paper it is coming. So that's the reason I was giving the high level of the questions here itself, so that it will be somewhat having some idea for you. Okay na? నేను లైవ్ పోస్ట్ చేసి పెడతా అరౌండ్ టైం 6:30 7 అని చెప్పేసి 6:30 7 అని చెప్పేసి పెడతా. మీరు దాన్ని చూసుకొని వచ్చేసేయండి. Any other who are in the live, if they are having any concern they can ask, remaining they can leave. ఎవరికన్నా లైవ్లో ఉన్న వారికి ఏమన్నా కన్సర్న్స్ ఉంటే దే కెన్ టెక్స్ట్. ఎవరికన్నా ఏమన్నా కన్సర్న్స్ ఉంటే అడగొచ్చు. రేపు ఒక అరోమాటిక్ న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్ ఒకటి, అరోమాటిక్ అడిషన్ ఎలిమినేషన్ రియాక్షన్ ఒకటి, న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్ విత్ ద బెంజైన్ మెకానిజం ఒకటి. గుడ్ నైట్ రా ప్రణీత్, గుడ్ నైట్. మ్యాథ్స్ ఫిజిక్స్ కూడా బ్యాలెన్స్ చేయి, మ్యాథ్స్ ఫిజిక్స్ కూడా కంప్లీట్ చేసేసేయి. నీకు ఆల్మోస్ట్ హాలోఅల్కీన్ హాలోఅరేన్స్ రివిజన్ అయిపోయింది. ఒకసారి పాలీ హాలోజన్ కాంపౌండ్స్ కూడా ఒకసారి చూసుకో. పాలీ హాలోజన్ కాంపౌండ్స్ నేను అది ఇప్పుడు గ్రూప్లో పెడతా, అది ఒకసారి చూసుకో. యశ్వంత్ నువ్వు ఒకసారి నాకు మెయిల్లో ఒకసారి హాయ్ అని పెట్టమ్మా, నేను నీకు ఒకసారి పర్సనల్, ఇక్కడ ఇది లైవ్ కాబట్టి మనకి లైవ్లో వద్దు, లైవ్లో నెంబర్ అవి షేర్ చేయలేను. ఎనీ అదర్ హూ ఆర్ ఇన్ ద లైవ్, దే ఆర్ హ్యావింగ్ ఎనీ కన్సర్న్స్ అబౌట్ ద క్లాస్ ఆర్ ఎనీథింగ్? ఏమన్నా డౌట్స్ ఉన్నాయా? కన్సర్న్స్ డౌట్స్ ఏమన్నా ఉంటే అడగొచ్చు. ఏమన్నా కన్సర్న్స్ కానీ డౌట్స్ కానీ ఏమన్నా ఉంటే అడగొచ్చు. లేవు అంటే ఐ విల్ ఎండ్ ద సెషన్, ఉన్నాయి అంటే ఐ విల్ బి దేర్. ఓకే సార్, డన్. ఏమన్నా కన్సర్న్స్ ఉన్నాయి అంటే దే కెన్ టెక్స్ట్, ఇఫ్ నాట్ దే కెన్ లీవ్. ఎవరున్నా లైవ్లో ఉన్న వాళ్ళు ఒకసారి, ఇఫ్ ఎనీవన్ ఈజ్ ఇన్ ద లైవ్, ఇఫ్ యు ఆర్ హ్యావింగ్ ఎనీ కన్సర్న్స్, ఇఫ్ యు ఆర్ హ్యావింగ్ ఎనీ కన్సర్న్ you can text me, if not I will leave. No, right? I will leave tomorrow, sir. Okay nana, నేను లైవ్ షెడ్యూల్ చేసి పెడతాను by 6:30, max to max 6:30 or okay, max to max 6:30 or 6:30 లేదంటే 7కి షెడ్యూల్ చేసి పెడతాను. ఒక హాఫ్ అన్ అవర్లో ఆ కాన్సెప్ట్ కంప్లీట్ చేసేసుకొని క్వశ్చన్ స్టార్ట్ చేసేద్దాం. ఓకే, డన్. ఎండ్ చేయనా? షుడ్ ఐ ఎండ్ ద లైవ్? Should I end the live, the one who are in the live? ఒకసారి చెప్పండి, ఎవరైనా లైవ్ లో ఉన్నారా? ఎనీవన్ ఆర్ ఇన్ ద లైవ్? ఓకే, ఫైన్. నౌ ఐ వాజ్ ఎండింగ్ ద లైవ్. See you tomorrow. Bye. Bye. Anyone if you are in the live?